This talk is titled Regvue, Modern Hardware-Software Interface Documentation. My name is Rob Donnelly. I work at NASA's Jet Propulsion Laboratory, where my primary role is FPGA verification. A lot of what I'll be showing today was implemented by Josh Geden over a summer internship. First, we'll start with a debug story. A test engineer was performing manual tests of some error logic in physical hardware, and they weren't able to clear the error status bits. This was a bit odd because the logic was fairly simple. It had already been verified. However, I went back and took a look at the RTL, and sure enough, I couldn't see how this couldn't work. I went and reran the simulations, and they passed. Right, everything worked. So finally went back to the commands that were being entered to perform these operations to clear the error status bits. And upon closer inspection, realized that there were some typos in the right data values. So for example, one was missing a 0, right? So a 10,000 became a 1,000, and so we ended up writing to the wrong bit. In another case, the 0x prefix was, forgot to type the 0x prefix. And because this was a tickle, this was being done through a tickle interpreter, instead of being interpreted as decimal, it was interpreted as octal, which further compounded our confusion. And that wasn't very obvious. So this engineer had mistyped the values, and when I initially looked at them, I misread them, and so I did not immediately catch the mistake and spent all this time investigating. And after eliminating all possibilities, went back to square one and caught this issue. So this story is just one instance of many where we're making silly mistakes, and we waste a bunch of time trying to resolve them, trying to figure them out, and then trying to resolve them. And so we as humans, we're prone to making errors, right? And especially after, it's been a long day, you've been pounding your head against a problem, you've been looking at this screen for hours, and the longer that you're banging your head against something, the more prone you are to making errors. Right? And examples of this is, like we just saw, right? Decoding register values into field values and vice versa, decoding numeric values into symbolic values. Right? These are all very mechanical tasks that we're capable of doing, but we're also, there's a high probability that we could do so erroneously, and then waste a bunch of time doing that. And so over time, I've been noticing, these instances where we've been making these silly mistakes, and trying to pay attention to these events and trying to think about, how could we do things better, right? How could we limit these human errors being introduced? And then over time, looking at other instances where we have inefficiencies, right? So inefficient information sharing, sharing design spec information with someone, right? We have to, either email them a document, or ideally we're sending them a link to a document, and then making sure that everyone is looking at the same version of the spec, and then looking at the same section of the document, right? And so there's a lot of overhead involved with that. It may not seem like a lot, but over time, over a project, you have these small inefficiencies that build up over time. And especially if you get it wrong, then you have to spend time to get everyone on the same page. And then not only inefficient information sharing, but inefficient information access, right? So this documentation is, in these systems that are just inefficient. There's overhead into getting access to the information. if it's on some website and behind a authentication page, having to enter that information, or if it's just in a Word document and you have to wait for Word to load up, right? It's fairly quick, but not instantaneous. And then once you load the document in Word, you now have to go scroll through that document or go to the table of contents and find the information that you're interested that's within that document. And so it's all very inefficient. And if you're doing that, thousands of times over a project, those inefficiencies add up. So while paying attention to the needs, also paying attention to the solution space and all the alternatives that are out there, right? I've already mentioned PDFs and Word documents. We also have HTML as a solution, right? And that's also widely used for design specification information. But the problem is we're not using it to its full capacity, right? We're using it as just another PDF or just another Word document, right? It's static content. We do get some benefits out of that, right? We can direct link to a specific register, for example. But we could do much more with that, right? Modern web technologies is more than just HTML. It's also CSS, or cascading style sheets, to style the page, to style the content on the page. It's also JavaScript. All web browsers provide a JavaScript engine that we can use to deliver interactive content. So we can have a mix of both static and interactive content on the same page. And we can do this fully on the client side, right? We don't need any code running on the server. We can do it all within the web browser because of those three things, right? HTML, CSS, and JavaScript. So with those three technologies, created something called Regvue. And this is a screenshot of Regvue that is presenting design information for an open source RISC-V system on a chip. And we'll dive more into this as we progress. But first, I want to do some comparisons between traditional solutions and the Regvue solution. This first example is from a PDF I found out on the internet for a system on a chip. And this is register documentation for an SPI control register. And this is pretty typical of what we're used to seeing for register documentation. Nothing really too terrible here, but it has room for improvement. The biggest one for me is the short cryptic field names, right? What is SSI? I have no idea. I got to go scroll down and look it up, right? So this solution chose presentation over meaningful field names, meaning that to render this register layout view, right, they had to make a trade-off between presentation and meaning, right? And they chose presentation, right? So to fit everything within the width of the page, they had to use short cryptic identifiers for the field names. And also note that this is for 16 bits only, right? If you were to do this with 32, your problem would be further compounded. Another problem here is they provide the reset value. It's all zeros, so it's really easy to figure out what the fields are going to be at reset. But if the reset value for the register was non-zero, it would take some work, however little, to convert that from a register reset value into field reset values. Here's another example I found out on the internet. This is from an HTML document for an open source SoC design. And here they took the opposite approach, right? They chose meaningful field names over a nice presentation. And so you can see bit 31, long field name, but to render it in the register layout view, it's been truncated and the text overflows into another field. And another example of this, quite coincidental, is that there's a field called overflow where the text itself overflows in bit 0 there. And this doesn't even provide a reset value for the register nor the fields. Now here's that same register, but in Regvue now. And in Regvue, you can have your cake and eat it too, right? You can have both meaningful field names and a nice presentation. So if the field name is too long to fit within the cell, we simply rotate it, right? We go from horizontal to vertical. Another thing that we do here is we show the reset value not only for the register itself, but also for all the fields. So we have a row for field values and a row for the register value. And then at the top left, we show the full symbolic path, where this register fits within the design, right? So this is the RX stat register, and it's within the audio block of registers. And then in the register detail view, we can sort by bit. So if we want to see it least significant first, we can do that, or most significant first, we can do that. We have one more comparison. We looked at registers. Now we're going to look at address map. And this is an example address map taken from the same PDF that I showed earlier for the register example. Again, not too bad. It's verbose. Sometimes verbosity is good, especially for specifications. But the biggest problem with this one is that all the detail is elsewhere in the document, right? So, I mean, it's nice that they have links, but you have to context switch back and forth. Now, if we look at Regvue, we have everything side by side. You have the address map on the left. It's a simplified address map. And then you have the detail for the register on the right. And the address map is hierarchical, a tree view, if you will. So you can, get the 10,000 foot view, right? See all the blocks in the system. And if you want the detail, you can expand each individual block and see subblocks and subregisters. We don't have time to go over all the features, but there are a few features that I want to highlight to give you more a feel of what you'll find in Regvue. There are 3 ways to get to the information that you're interested in Regvue. The first is through a direct link. So if you save a direct link to something that you've already found, or if someone shares a direct link with you, you can use that to get directly to the information that you're interested in. The second is through browsing. So you can use the hierarchical address map to drill down to the information that you're interested in. And the last is search. So I'm part of the search generation, right? I don't categorize anything. I don't label anything. I just search for everything. And so Regvue supports that out of the box, and everything can be driven through hotkeys. So if we press Control K, that will load up the search view. And Regvue implements something called incremental search, which means the search results get updated as you type, right? So we will search for the term error, and with each letter of the word error that we type in, the search results are going to get updated, right? So the more you type, the more refined your search becomes. And you can use that as a feedback loop to adjust your search term based on the search results that are coming back. So if we start entering the word error, we can see that the search results get updated as we type. And the more we type, the more refined the search becomes. And we land on, we see that the top search result is what we were looking for, query error. So we'll hit return on that, and Regvue will immediately load the detail for that register. Something to note here is that this is all running client-side in your web browser. There's no queries being sent out to a remote server. This is all running within the web browser itself. The second feature I want to highlight is responsive design. Responsive design means that the page will render nicely on any screen size, whether that's an ultra-wide monitor or you're viewing this on your cell phone. It's going to look nice on any screen size. So we're going to show that by shrinking this window from left to right. And in particular, I want you to focus on the count source field. And in the widest view, the count source field is horizontal. But as we shrink the window down, we run out of space to render the count source field name horizontally. So we rotate the field name, so now it's vertical. The other thing we've done here to get more horizontal space to render the registered layout view is to hide the address map. And if you want to go, bring up the address map again, you can either make the window larger, or you can click this button in the bottom left of the window to temporarily display the address map. Now, if we shrink the window even further, we've already rotated all of the field names, so we can't do that to get more horizontal space, but we can shrink the font size for the register layout view. I'm only showing 3 keyframes here, but this is really slick to see it animated in real time. The third feature I want to highlight is the encoding and decoding of field and register values. And we'll demonstrate this by first starting with the PSC field. And we'll change the value of the PSC field from a 0 to a 1. And as you type, the register value gets updated to reflect the field values. So when we change the value of the PSC field from a 0 to a 1, we can see that the register value got updated to reflect that. And now we'll show this going the other way, going from register value to field values. So now if we select the register value and we clear it out, Regvue does input validation. So before updating the field values, it'll first validate your input. And in this case, it's an empty value. So this is not valid, and it will tell you as such. And then so we start to enter a hexadecimal value. So we start by entering the 0x prefix. And this value as it stands now is still invalid, but for a different reason. And Regvue will tell you what's wrong with the value. Now, if we type 8002 after that, we can see that as we type, the field values are getting updated with this new register value. So a value of 0x8002 has the 8 is now in the cap source field. Now, if we finish entering the rest of the register value, the remaining 32 bits, so here we're now typing in underbar ABCD, and we can see now that the cap source field is A, and that bit 31 is now 1, and so on. This is really nice for if, for example, you want to construct a register write value in terms of fields. So if you wanted to write, say, the count source field with a specific value, you could specify that. You could update the count source field value to whatever value you wanted, and it would automatically calculate the register value for you. And you can now take that register value and use that as your write data value. Similarly, going the other way around, so if you're reading a register and you read back the raw 32 bits and you want to know what the corresponding field values are, you just copy and paste it into Regvue, and the field values will get updated immediately. The last feature I want to highlight is direct permalinks. Direct meaning you can link directly to specific design elements, and perma as in permanent, and that this link will never change throughout the life cycle of the design, as long as you keep the register names and the field names the same. So anytime you select a design element in Regvue, the URL will be updated to point directly to that design element. And so now you can take this URL, you can copy it, and you can share it with someone else. And when they click on it, it will load up Regvue to the same view that you have in front of you. Right? So here we have the IDR field selected. And so if someone else clicks this link, they will also get the same page with the IDR field selected. The URL is broken up into several components. The first component on the left is the Regvue application itself. The second component is the hierarchical path to the register within the design. The third component in this case is the field. So this is the IDR field. The last component is a URL to the file that contains the register description information itself. And this is a JSON file or JavaScript object notation. A little bit more detail on the file format that Regvue uses. So again, it's JSON or JavaScript object notation with a custom schema just for Regvue. And that schema is well documented. You can see the table of contents for the documentation on the left-hand side. And on the right is a very simple but complete example of what this JSON file might look like. So you can see some elements toward the bottom, like we have two registers on the bottom, and both of those registers have one or more fields in them. And you might ask yourself, why develop a custom file format for Regvue? Why not use an existing standard like IPExact or some other register description language? Well, the answer for that is twofold. The first is that Regvue is a web application that runs inside the browser using JavaScript. And JSON is a format that JavaScript can natively deserialize out of the box. You don't need an external library. And the second is that we wanted to minimize the amount of processing necessary to transform this input into the internal representation that Regvue uses. Regvue is now used by several projects at JPL, but the biggest by far is Europa Clipper. Europa Clipper is a spacecraft that will study Europa, a moon of Jupiter. Europa has a thick, icy crust, but beneath it is a liquid water ocean. On Earth, almost everywhere we find water, there is life. So the idea being, if you want the best chance to find life elsewhere in the solar system, you seek out the water. This is a high-level overview of the Europa Clipper computer system. At the top, we have the spaceflight computer, which is connected to several boards that have one or more FPGAs. These FPGAs offload various functions from the processor, including the collection and storage of science data, firing thrusters, turning reaction wheels, and providing communication with Earth. Design information for Europa Clipper is spread across multiple Microsoft Word documents. And if you're working at a system level, this isn't an ideal situation. But with Regvue, we can put all of this design information into one place. This diagram shows all the Word documents at the top. With various applications and scripts, these Word documents get transformed into the Regvue JSON. And then we have a hand-created top-level JSON file that then includes all these individual JSON files. This top-level JSON file is what gets loaded into Regvue. Regvue is currently in the process of being open sourced. Once it's open sourced, it'll have a permissive license. It'll likely have the Apache 2.0 license, and it'll be made available under the NASA JPL GitHub organization. In summary, Regvue is a modern hardware-software interface documentation solution. It increases not only individual efficiency with features like incremental search, but also team efficiency with features like direct permalinks. Regvue also reduces human errors with features like field and register encoding and decoding. Lastly, Regvue is a permissively licensed open-source solution that the community is welcome to enhance and EDA vendors are welcome to leverage. Funding for Regvue was provided by both the Europa Clipper project and the Mars Sample Return project. Thank you.